Welcome to Chapter 17, and we are changing gears here in Chapter 17. What we are going to start focusing on is waves and sound and light and electricity. And if you take physics and you break it into two categories, you have what we call kind of mechanics, which deals with forces and velocities and distance and acceleration and momentum and pressure and all that stuff that we covered. And the other half is kind of sound, light, electricity, and magnetism. And that's what we're going to focus on for the last remaining month and a half of the school year is sound, light, electricity, and magnetism. But before we even get into sound, we have to talk about waves because sound and light both travel as waves. So when we talk about waves, there's a few different types of waves that we are going to talk about. And the first one is a mechanical wave. And what is a mechanical wave? It's a disturbance through matter that travels or that carries energy from one place to another. So a wave has energy on it and it's carrying it from one place to another. And when it carries it from one place to another, it's traveling through a medium. And a medium is what a wave travels through, such as a solid, a liquid, or a gas. There are some waves that do not need mediums to pass through. However, all mechanical waves need a medium to pass through. So all mechanical waves need a solid, liquid, gas to pass through. For example, in outer space, when there's a vacuum, there's nothing for it to pass through. So that's why a sound is a mechanical wave, and mechanical waves do not exist in outer space because they don't have a medium to travel through. There's nothing in space. It's a vacuum. It's void of everything. And a mechanical wave is simply caused by a vibration through a medium. So if you clap your hands, what are you doing when you clap your hands? When you clap your hands, you are causing air molecules to vibrate. You're pushing air molecules out, and you are causing them to vibrate, and that is traveling through the air. So a mechanical wave must travel through a medium. What is a medium? It's anything a wave travels through, such as a solid, liquid, or gas. Types of mechanical waves, there's two types. There's transverse, which travel up and down. So transverse waves really kind of travel a wave that vibrates at right angles to the direction it's traveling, which means it's going like this. If the wave is going this way, the wave is going up and down like that, just like you should think of. Now, when we talk about transverse waves, I'm also going to review components of a wave. You might have learned this in 6th grade, but this is going to be good for you to know. There are 4 components of a wave that you need to know. Crest, and the crest is the top of a wave. Trough. Trough is the bottom of the wave. Then, you need to know wavelength. What do you think wavelength is? It's simply the length of a wave. But how is it defined? It's defined crest to crest or trough to trough. So top to top or bottom to bottom. That gives you the wavelength. Right? And then the last thing I would like you to know is amplitude. And amplitude is kind of the height of the wave. Now, you have to imagine that if we put a line through the middle of the wave, that's kind of the waist of the wave. So the amplitude is either up or down, but it's not the whole height because the origin of the wave is this red line. The more energy a wave has, the higher its amplitude. So the more energy a wave has, typically the higher its amplitude, but the amplitude is kind of half the height of the wave. So that's the amplitude, or this is the amplitude, the height of the wave, how far it's displaced. So we have crest, trough, wavelength, amplitude. Kind of the 4 things to know there. Crest, trough, wave, and amplitude. So the first type of mechanical wave is transverse, and that's when it's traveling. It's going up and down in the direction it's traveling. The second type of wave is longitudinal. And longitudinal, the molecules are vibrating parallel. So if the wave is going like this, where a transverse wave was going up and down, a longitudinal wave is going to lay flat. So we will kind of go over these in class a little bit, but a transverse wave is going to go, the molecules are going to travel parallel to the direction the wave is flowing, and it's going to be kind of flat, right? Side to side, where a transverse is going to be up and down. And then the last type of wave that we can have is a surface wave. And that is simply just a wave that travels along a surface separating two medium. And a very simple example of a surface wave would be the ocean and air. Ocean and air would be a surface wave. So just an example of the three types of waves. We have transverse waves, longitudinal waves, and surface waves. And then, if we're going to break down, you'll need to know the four components of waves, which are crest, trough, wavelength, and amplitude. That's 17.1. That's your introduction to waves. And this is Mr. Kleinert, and I'm signing off.